Hello everyone, this is Mohit Rajput from Electronics and Communication Department, JCRC College. Today we will discuss about the Huffman coding that comes under the image compression and digital image processing. Huffman code is a source code that is the most popular technique for removing the code redundancy in digital image processing. When coding the symbols of an information source individually, Huffman coding yields the smallest possible number of code symbols as per source symbols. In terms of the noiseless coding theorem, the resulting code is optional for a fixed value of n, subject to the constraint that the source symbols be coded at a time. Huffman code is a source code to create a series of the source reduction by ordering the probabilities of symbols under consideration, combining the lowest probability symbols into a single symbol that place them into the next reduction. This code is optimum as it provides the smallest average code word length for given discrete memoryless sources. Now we can consider that we have a discrete memoryless source with having the five symbols or five messages m1, m2, m3 and m5, and these are the probabilities: point 0.4, point 0.2, point 0.2, point 0.1 and point 0.1. These are the probabilities of a discrete memoryless source to generate these messages m1 to m5. Now we have to find out the code word for all these messages so that we can easily find the entropy and the average code word length to find out the efficiency of discrete memoryless source. And when we can find the efficiency, then we can easily find the code redundancy for this particular source. To find out the code word, first of all we have to arrange all these probabilities in the decreasing order. In stage first, we have to arrange the probabilities in the decreasing order. After that, what we have to do, in second part, we have to add two lowest probabilities, and again in second stage we have to arrange in the decreasing order. As you can see that point 1 and point 1 are the lowest probabilities. We have add these two probabilities and put into the next stage 2 in the decreasing order. We have to repeat this process until we get lowest two probabilities in the stage 4. We have to repeat this process up to the stage 4. After that, when the coding parts come, we have to assign 0 to the upper part and 1 to the lower part, which all the probabilities where we have combined the two lowest probabilities in the next two stage, we have to assign 0 to the upper part and 1 to the lower part. Now when we have to find out the code for a particular message or a particular symbol, then we have to move backward. Means we have to come from the stage 4 to stage 1 to find out the code of a particular symbol. For example, we have to find out the code of m5. You can see that we start from the stage 4, point 6 to point 2, point 2, point 1. Means the path which we have followed in the starting points to arrange the probabilities. Now for the coding part, we have to move backward from the stage 4 to stage 1 to find out the code. Means m5 code is uh, 0 1 1 0 1 and this 1. 0 1 1 is the code for the m5. m4 code is 0 1 0 0 1 0. m3 code is 1 1. m2 code is 1 0. m1 code is 0 0. These are the code for the all the messages which is given in this table. Now we have the code is M100, M210, M311, M4010, M5 is the 011. Now we can easily find out the entropy, as we know that what is entropy? Entropy is the average information, and it is denoted by the capital H. We can mathematically calculate the entropy. K is equal to 1 to 5 pk log 2 1 by pk. Mathematically, we can calculate this value is 2.12. Now we can find out the average code word length. Average code word length is denoted by L, given by k is equal, summation k is equal to 1 to 5 pk into length of the mk in bits, where length of the mk is the number of digits, number of bits in the each code, that is known as the length of the mk bits. Means we can see here that M1 has the code 00, M2 has the code 10, M3 has the code 11, M4 has the code 010. Means the value of the length of the code is M4 is 3, M5 is 3, M3 is 2, M2 is 2, and M1 is 2. Means how many number of bits in the code, that is the length of the code. We can easily find out the mathematical expression of L, and this value is 2.2. Now we can calculate the ratio of entropy and the average code word length. The ratio of the entropy and the average code word length is known as the efficiency of the that particular source. Means efficiency is 2.12 by 2 by 2, that is 0.963, and we can easily find out the code redundancy, that is 1 minus of eta, means 1 minus of 0.963, that is 0.04 approximate, that is the code redundancy. The Huffman procedure thus creates the optional code for a set of symbols and probabilities subject to the constraint that the symbols be coded one at a time. After the code has been created, coding and decoding is accomplished in a simple lookup table manner. The code itself is an instantaneous, uniquely decodable block code. It is also called a block code because each source symbol is mapped into a fixed sequence of the code symbols. It is instantaneous because each code word in a string of code symbol can be decoded without referencing succeeding symbols. It is uniquely decodable because any stream of code symbol can be decoded in only one way. Thus, any string of Huffman encoded symbols can be decoded by examining the individual symbols of a string left to right manner. This is all about the Huffman coding. Thanks.